All right, what's up, guys? 8.2b. Let's do it. The ambiguous case is not going to be heavily emphasized on the Chapter 8 test or the 8.1 and 8.2 quiz, which I need to figure out when that's going to happen. I don't have it here with me. Pretty sure it's going to be... I'm not going to guess. I'm just going to post it after I post this. Excuse me. So take a second, pause me to copy that. All right, so last time we talked about the law of sines, and we said these are the three types of triangles that we use law of sines for, and we drew pictures, and we talked about the angle side pair, where there's an angle and a side across from it that's given to us. And I mentioned that this one we were going to talk about later. So remember I talked about, well, we usually write it SSA because we don't want to deal with silly freshmen in geometry. You said, but that one, this just helps me remember that this is the one I have to watch out for. It's a bad word. I have to watch out for it. So when we have an angle side set up, there's three things that could happen. There could be no triangle. There could be one triangle, or there could be two triangles. And I'm going to talk about those cases. What happens with no triangle is basically you're given two sides and an angle, right? So you're given side, angle in here. And then this side ends up being not long enough to connect. So there's all these visuals in your textbook that show you a much better visual than this. And there's even this formula where, like, if the height is equal to, I don't even know it because I think I've made it very clear that I don't like memorizing stuff just to memorize. If you're good at memorizing stuff, look that up and memorize it because it could be helpful. I'm going to show you what I do instead, and to me, this is so much easier than memorizing stuff. Okay, so let's draw a picture. So the first thing we need to recognize is this is an angle side setup. That's where I know I'm going to need to watch out for any of these possibilities here, okay? If it's either of these two, I just do my problem like I did the last time in 8.2a, and I don't need to do the extra step. These are S's for side, by the way, okay? So we're going to set it up like we normally do. We're not going to do anything. So it's going to be, we have an angle side pair that's given, right? So sine of 58 over 26. And then we have, grab another color. We know B, so we need to next work on side B. We don't know either angle or side C, so it makes no sense to look at C. It only makes sense to look at B. So we're going to go sine of B over 29. So setting it up exactly like we did before, we're going to cross multiply. We're going to start getting B by itself. So this is attached with multiplication. We're going to undo that by dividing. Don't bust out your calculators yet. Okay, so dividing to get rid of that 26 that's attached with multiplication. And then now pause me for a second and think about how we're going to get the B by itself. Pause me. Okay, how are we going to get the B by itself? We're going to do sine inverse to undo the sine. We got to do it to both sides. Sine inverse and sine cancel out. So we end up with B equals sine inverse of 29 sine 58 over 26. Okay, so I'm going to take out my calculator. Hopefully I don't have a weird glare. Oh, good. I don't have a weird glare like last time. I'm going to do the inside of the parentheses first. I could do it all, but I want to show you something that's going to come up with one of the three cases. So I'm going to go 29 sine of 58. Let me make sure I'm still in degree mode. Yep. 29 sine of 58, all divided by 26, and I get 0.945. Now, I'm not going to round, because if I round and then take the sine inverse and then round again, you all know it's going to be less accurate, right? But I want you to see. I'm going to take sine inverse of this now, right? Because this decimal is what's in this parenthesis. It's all of this stuff in the parentheses. I am allowed to take sine inverse of this because it's between -1 and 1. I am allowed to take sine inverse of this because it's between -1 and 1. So I can go sine inverse of that answer, right? I'm getting the exact value because I'm not rounding. And I get 71.067. Okay? What happens if this number that I get when I punch this parenthesis into my calculator is greater than 1? Well, think about the sine graph. We know the sine graph does this, right? In between -1 and 1. So if this number right here is not between -1 and 1, and I try to do sine inverse of that, my calculator is going to give me an error. So let me just make up a number. That is not between -1 and 1. My calculator doesn't know what to do. My calculator doesn't know what to do. You can't find sine inverse of a number that is not between -1 and 1. That's when you're going to have no such triangle. So there's two ways you're going to see no such triangle. I'm not going to do an example of this. There's two ways you're going to see this. Either you type this into your calculator before doing the sine inverse, you type this into your calculator, and you see that it is outside of the window from -1 to 1. That is a trigger that you're not going to be able to take the sine inverse, and the answer is going to be no triangle. If you don't recognize that, and you go sine inverse of this number, right, and you get an error on your calculator, that is also how you know the answer is no such triangle. Okay, so there's going to be probably a couple of those on the homework. I'm going to cut the assignment way down so that you probably have about 2, maybe 3 of each of these types. Okay, so if you do sine inverse on this step and you get an error on your calculator and you're certain you typed it in correctly, that means that the triangle can't be made out of the information that's given. It's not possible. Okay. Okay. We did get a value between -1 and 1, so we were able to do the inverse. Now, if we were not on an ASS triangle here, we would just keep going. We would find, let's see, we found angle B, so we could easily find angle C using the triangle sum, and then we could use law of sines to find side C. Since this is an ASS, we have a red alert. We need to look at 2 possible options. So let me show you what's going on here. We did sine inverse. Let me find that decimal again. 0.945, right? 0.946. You know what? I'm going to write that right here. Okay. So this is saying the ratio of sides is 0.946, and it's asking me for the angle. So I need to think, okay, the ratio of sides is 0.946. Where is sine positive? So let me draw a picture for this. I could have 0.946 over 1, my y over r, right? Or I could have the exact same triangle, same side lengths and everything, over 1, whoops, 0.946 over 1 in the second quadrant. The calculator is giving me 71 point, I'm just going to write 71 point because I don't have space. I don't want to make it messy. The calculator is giving me this, 71.067. The calculator isn't smart enough to know that there's 2 possible answers though. So this reference angle here is also 71.067. What we need to do is figure out what the measure of the angle in standard form is, which means we want this angle right here. So this is our first possible value of B. Our next possible value of B is this green angle right here. And the way that we find that green angle is saying this is 180. The reference angle is 71.067. So we want to go 180 minus 71.067 to figure out what the green is. The entire thing, straight line, minus the pink gives me the green. So I'm just going to do that on my calculator. My second possible value for B is that. So I have two different triangles here. Okay, and I'm going to show you what this looks like when there's one triangle as well. So to sum it up, I would love for you to understand this, but it may not be possible, and that's fine. To sum it up, when we have angle side side, we solve for our first angle, okay, the one that has the side across from it. We do sine inverse. If we get an error, that means there's no such triangle. If we don't get an error, we need to do 180 minus that angle to find the second possible angle. Okay, rewind that and listen to it again. So I'm going to draw a second triangle. I probably should have left more space over here. So this 71.067 is the B in my first triangle. And the C and the C are going to also be in my first triangle. My second triangle still has the A, all of the given information. So I still have the 58, that's given. I still have the 26. I still have the 29. But now my B2 for my second triangle is 108.933. Okay? So I'm going to keep color coding this. So my C for my first triangle is really easy to find, right? I know the two angles, so I'm going to go C1 equals 180 minus 71.067 minus 58. I'm going to do that on my calculator. I already did that, didn't I? Okay, so there's that. My C1 is 50.933 degrees. I got my B1. And then fill it in to make sure. So one of the biggest mistakes people make on this. Oh, this is going to be a little bit long, isn't it? Sorry, guys. I'm trying to keep the videos under 15, but that's not going to happen this time. One of the biggest mistakes people make on this is that they don't find all of the information. So that's why I keep the pictures going, because I can see that I don't have side C yet in this triangle. Okay, I'll do that in a second. I don't want to run out of space over here. So let's find the C2. So over here, I'm going to say the C2 is 180. Minus 108.933 minus 58. I'm going to do that on my calculator. My C2 is 13.067. Okay, and then now all I have left to do is find side C for each of the triangles. So let's keep it together over here. I can find side C by going sine of 13.067 over the C2, little c, right? Now, please use the given information. I could use the A and the A, or I could use the B and the B, but this is an estimate. This is already rounded. Neither of those are rounded. Okay, so always go back to the given information when you're finding the last value. And then cross multiply and solve. I'm not going to show work for that because we did that a ton last time. I'm just going to type it into my calculator and get that C2 is 6.932. And I'm also going to add that on my picture because I want to make sure, like I talked about last time, the largest angle should be across from the longest side, and the smallest angle should be across from the shortest side, and that checks out. So we're good with our first triangle. Our second triangle. All of this green stuff is for our second triangle. Now for our first triangle, we're still missing side C. Sorry, this is kind of messy, but I'm going to do it over here. So for side C, I'm going to go sine of 50.933 over little c1. And again, using the given information so that I'm not using estimates when I can avoid it. Okay. So to find side C, same thing, I'm going to cross multiply and solve. And again, we did that 800 times before, so I'm not showing you work for that. And I get side C is 23.804. I should have organized my work a little bit better here. I don't really have space. Let me see if I can like squeeze it in somewhere. Triangle, I can't spell either. I'm just gonna come up with a lame abbreviation. Okay, triangle 1 has angle B 71.067, angle C 50.933, and side C 23.804. And then triangle 2 has angle B 108.933, angle C 13.067, and side C 6.932. So that's the summary. And just to double check over here, let's put the 23.804 and confirm. Okay, what's the longest? The largest angle is 71.067, and that is the longest side. The smallest angle is 50.933, and that is the shortest side. So we're good there. Whew, that was a long problem. All right, let's see what this next one looks like. Obviously not as much space, so hopefully that's encouraging, right? We have, I'm going to draw it a little bit larger so that it's not so crammed in there. 105, that's clearly not to scale, right? This is not a 105-degree angle, but I kind of don't really care. And then this is going to be side C. So again, we have that angle side pair. We're given angle side side. So that's when we know we have our red alert. We might have 0 triangles, we might have 1 triangle, we might have 2 triangles. So I'm going to set up sine of an angle divided by the side across equals sine of an angle divided by the side across. And again, I'm not using the C's in this because I don't know either of them. I need to know one of the two. Okay. And then I'm going to cross multiply and solve. Divide sine inverse of both sides. And then if you want to, you don't have to do this, but I just want to point it out again. Find the value of that fraction inside. It is between -1 and 1, so I am not going to get an error. If that fraction is not between -1 and 1, and I try to do sine inverse of it, my calculator will give me an error, and that's how I know there's no such triangle. So I'm going to go sine inverse of that answer, and I don't get an error. Angle B is 46.698 degrees. Okay, now I always need to check 180 minus. Unless I get an error, which means there's no such triangle, and I stop doing the problem, I always need to do 180 minus. So I'm thinking that there might be a second triangle. So I'm going to go 180 minus, and I get that as my second B. But wait, look over here, pause me, and think about this for a second. Okay, can I have angle B be 133.302? Is it clicking? Is that going to work? 133.302 here and 105 here. Nope, that's bigger than 180, and I haven't even included angle C yet. This is how I know that there is only one triangle. So write yourself a note. This value is too large, which means there's only one triangle. This value is too large to fit inside of the triangle with the given information. Rewind that and listen to it again. So that's how I know that this is not going to happen, and I only have one triangle. So I now know that this is 46.698. I'm going to find angle C by going 180 minus. I'm going to get 28.302. Let's write that down. Angle C is 180 minus, 105 minus 46.698. And I'm running out of paper. We're going to find side C. I'm not going to do the work for you because you've done this 1,000 times now. We're going to go sine of 46.698 over side C equals, again, using the given information instead of the rounded information, using angle A and side A instead of angle B and side B. And then you guys can all solve that. I'll do it for you really fast so that you know you got the right answer. You should get side C is 54, actually it's 55. It's 54.9997, so it's 55. And that doesn't make sense. I just did something wrong. Hold on. Oh. What did I do? Hold on. You know why I know that doesn't make sense? Because it... Oh, 73. I'm looking at the wrong thing. 73. Okay. But then these two are equal. Okay, I'm going to have to figure out what's going on here. Hold on. We got, let me make sure I typed this in right. $46.698. That's side B. Then we did sine up. It's because I mixed these up. Yeah, duh. Okay, do you see what I did there? I used angle B, so of course I got 55. Side B is across from angle B. I needed to use angle C. 28.302 goes there, right? Sine of angle C across from side C. Sine of angle A across from side A. Sorry about that. So let me, 73... So side C is 35.832, and we can look over here. Let's see, largest angle, longest side. Yep. Smallest angle, shortest side. Yep. So there's the information. Did I write down angle C anywhere? I didn't. This, sorry guys, this is so messy. Ugh. This gave me 28.302 degrees. Okay. All right. That was 8.5 minutes longer than what I try to do usually, but there's no way around it on this one. All right. So I'm not going to reiterate anything. Just go back and re-listen to stuff if you need it. Hope you guys are doing well, and I will see you later.